At this point, I'm going to wire the boat up. Wiring the boat up is something I'll do towards the end once most of the other things are in place and I know where all my components are going to be, so I can figure out the correct wire lengths. So just showing quickly here what it looks like in Congo. This is kind of a rat's nest with these wires. They can probably be cleaned up a little bit. But just want to show what the end product is going to kind of look like, so you can better understand things moving forward. So I use a common waterproof box on all my capital ships. It has a set of standard connectors that I can use, and then this keeps the gun boards and then other switches for like a brushed pump and the receiver. It keeps those dry. These ones, it's a basic electrical box. They've worked pretty well. I've only at most got a few drops of water in there. And then you can see I also have all the individual components also waterproofed, kind of like defense in depth. So waterproof boxes aren't used that much anymore because the individual waterproofing techniques on various components have improved a lot. But I just wanted to give the context of how I'm approaching this. So this boat has kind of more traditional wiring where you end up with kind of like a rat's nest of various wires. I'll show on another boat what it looks like with an integrated board from Battler's Connection, which can make things a lot more simple. In Radetzky I have an integrated BC board, which is this guy right here. So this board serves as power distribution. So all the breaking up of the power is handled by the board, which is nice. So it cuts down on the wires, even though this still might look a little bit like a mess. Up here you can see the receiver that's individually waterproofed with E6000. For Scharnhorst, I'm going to wire it up like Congo, so I'm not going to use the integrated board because I have these waterproof boxes already that are interchangeable. So what I need to do is pretty much connect the batteries to the speed controls and then also to the control box, and then run wires to the individual other components, specifically the solenoids, which are here. So I drew up a quick diagram kind of showing what my approach is going to be. I like to do this on a more complex wiring job. Going into this level of detail usually isn't necessary if you're using the BC board, or if you're doing something like a cruiser that has fewer components you need to worry about. So on this side I have batteries. So what I'm using for this is 3 packs of 2 cells of lithium iron phosphate batteries. So each pack is 6.6 volts, 15 amp hours. So I'm going to wire these up in series. So to wire up in series, you go from the positive of one to the negative to the next, and then the positive of that one to the negative of the next one. That'll give me 6.6 times 3, or 19.8 volts, mainly for the pump. But I also am going to tap off between batteries 2 and 3 so I can get 13 volts for the solenoids and some other components. So up here I listed out my loads. So main drive, ESC, I want 13 volts. I'm going to use 12 gauge wire. The aux drive, which are the outboard motors, I'm going to make connections for both 13 and 19.8 volts because I'm not sure exactly which ESC I'll end up using, so I'll just build the flexibility into the wiring harness. I can use 14 gauge for that because the current draw is going to be a lot less. For the pump ESC, I want to take advantage of all 20 volts, so I'll do that, and I'll use 12 gauge because that's going to be the biggest current draw in the boat. And then for control power for the solenoids, and then an aux circuit for either a pump relay or a light, be 13 volts, 18 gauge, which is smaller because the current draw is much less. So what I do here is kind of notionally map out to understand how those connections are going to work. So up top I have my 20 volt components for the pump and the aux drive. This branch right here will be like larger wire for also for the aux drive as an alternative, and then the main drive. And then this connection coming down here is for all the auxiliary loads, so the solenoids. And then I'll usually set up another circuit. It's labeled light there, so I can use it for lights for night battle. So the specific connections here, where I have the box labels, that's of course unique to my setup because of the way I wired the box. But in general, the principle is I have the plus or the red wire going directly to everything for the aux loads, and then I interrupt on the negative side. So to get from the load to the negative terminal of the battery, there's going to be some sort of switch, whether it's a firing board or I'm going to use some test switches. That's where the interruption is. So once I know like generally how the wiring is going to go, you want to put the components in the boat where they're going to lie, so you can make the wires the right length to connect them all. So see my batteries here. I want to make connections to these points without a ton of excess wire. I'm going to try to put my ESCs in the middle here to kind of keep them relatively close to the loads, so the cut down on the wire length needed. If I run out of room, the bow on the boat's pretty empty, so I could route wire up there. But in general, you want to try to keep all the wire run short because it's just kind of cleaner and less resistance. So the solenoids, I have those kind of sitting in their mounts, and then I trade these between boats. I already have connectors on them. And then the two forward solenoids are kind of up here. There's one of the wires and there's another one on the other side. And then all the box connections are going to be right here. For connectors, I use XT connectors. So this is an XT60. It's came to be, I don't know, maybe 3 or 4 years ago. It got to be popular. These are good connectors because they're polarized, so you can't plug it in the opposite way, which is something you definitely want in your connector. And then they're relatively easy to solder relative to other connectors, so I'll use XT60s for my main power, or my large loads, and then these little ones are XT30s, which I'll use for the aux drive, or the aux connections, and the connections to the box. And you can see I have corresponding connections for the various ESCs. Another important aspect of connectors that you need to be cognizant of is whether it's a male connector or a female connector. So, easiest way to think about this is think about like a wall socket. So think of a wall socket. The prongs for like a vacuum cleaner or something, they kind of stick out and then they go into the receptacle in the wall. So it's kind of the same idea. So for your batteries or your power source, you'll want the female connectors, which are those holes there. And then on your loads, you would use the male connectors. And then what's kind of tricky about these is we're really talking about the pins, not the housing, because if you look, like, this housing is kind of more female-like and this housing is more male-like, but it's really the pins that you're worried about. The reason is if you had hot power, if this was like to a battery or something, if a piece of metal, like a tool or something, hit between those two, it would short it out and you could damage the battery. Where with the female connectors, you can see they put that little hump there too. That makes it much more difficult. These are another type of connectors called like Anderson connectors. I used these on previous boats before the XD connectors came out. They're good, and you can see they have the nice red and black, which is kind of clear. But they're definitely more complicated to assemble, so kind of phase those out. Another important thing to note on the wiring diagram is how the different components are wired up, whether they're in series or in parallel. So it might be kind of hard to see, but in this case the batteries are in series and then all the loads are in parallel. In general, for loads for the boats, you always want to put them in parallel, not in series. Sometimes with brush drive motors, people will wire them up in series, but using parallel is kind of the preferred method. So by parallel, all the loads will be, if you have two loads in parallel, they'll be at the same voltage, or they'll see the same voltage. If you took two loads in series, the voltage drop across them would differ based off their individual resistance, which is not really something you want to happen. Batteries could be wired up either in series or parallel based off the batteries you use, what voltage you want, how much current you want. It just happens based off the batteries that I use that I'll wire them up in series, usually to get to at least 13 volts. But they can just as easily be wired up in parallel if I was going to run at like a 6.6 volt. So once I have my wiring plan set, it's another whole challenge to try to figure out which exact pieces of wire you're going to use, where you're going to route them, where the connections are going to be. Understand this is probably going to be difficult to follow along, so I'll just show what I'm kind of working towards. So wiring harness that I use briefly on another boat. But things I want to figure out are mainly where these like Y connections are going to be. And then you can see on this one, I think it was set up for probably 3 batteries in parallel, maybe. But you can just see there's like a lot of connections there, and you kind of want to be smart about how you make the solder joints and which direction you want the wires to go and what wire size you want for each thing. So the way I do this, I get my different wire set up. I use silicone wire from whatever that is. I get it from Amazon. This stuff's pretty nice though. Silicone wire is nice because it bends easy without cracking or kinking. So wire is something that I don't skimp on a build. and I've had really good results with this brand. So your different wire gauges, this is 12 gauge, so this will be for like main power to like a pump or main drive, something you want a lot of amp carrying capacity. The pumps sometimes can draw up to like 40 amps, so I like to use 12 gauge for that. 14 gauge is kind of like my more reasonable wire for a load, so maybe like the aux drive or something at a higher voltage, or kind of like a standard pump that's only going to draw like 20 amps or so. This is 18 gauge. This is what I'll use going to the solenoids. You could probably go lower, but working with wire that's really small is sometimes frustrating from soldering, so I like the 18 gauge. And it's a little bit more sturdy if you have to pull on it. And at the end I have 16 gauge. So this is kind of the wire I use least often because it's kind of just in the middle. So sometimes I'll use it as like my tap off for control power, and then I'll tap 18 gauge off that. So this certainly looks like a mess. I'll try to clear some of it out. So what I'll do is I'll pick what order the batteries are going to be in. So I picked this one as like my number 1 or the lowest one. This will be number 2, and that'll be number 3. So these 2 batteries will power everything, and then this battery will probably only power the pump because the pump is the largest load electrically. So what I'll do is you can see I've just cut different wire segments with my kind of plan. So one thing I have to do is I have to connect these in series. I have to go from this battery to that battery, so I'll kind of, have them lined up with the connectors going in the right way, and then I cut this wire right here to be that bridge connection. And then likewise, this thicker wire right here would go from this battery to this battery. But if you remember from the diagram, that's kind of this segment right here, and you can see all the stuff I have tapping off of it. So I have like this wire and these smaller ones that I'll use to tap off of that. And kind of likewise on the negative side, I need to connect to the negative of this battery as my like reference point, my absolute ground. And then I need to string that all the way up to the 20 volts, so sort of over here. And then I planned out various taps. I also kind of identified, so like the test switches are going to go right here, so I put little segments there. So what I'll try to do is get this main wire done first, and then identify. I'll make sure I have a tap off so it looks kind of like this, where you'll have, just kind of like a loose wire there, and maybe a loose wire. This I cut out of a boat, so that's why that's short. But I'll get it here and try to get the wire lengths about right. It's sort of a balance where you want the wires to kind of be as small as possible, but a wire that's too long will make it where it needs to go. You'll have some excess, but a wire that's too short, you're kind of in a bad spot. So from that, I'll end up usually making the wires probably longer than I have to. And I'm also trying to wire this boat up pretty quickly because I have an event coming up. So if you wanted to be more deliberate about it and you had more time, you could get the wire lengths kind of spot on at first, but I'll usually just build in a little slop and then try to manage it with different wire wraps or wire ties or something. And then if it's really bad, I'll consider resoldering something in the future. One of the more complex things to think about when soldering up the wire harnesses are figuring out when to put the shrink tube on. So the shrink tube helps insulate the connection, and you'll see every connection I use it on. What you need to think about when you're doing these Y connections is how you're going to, one, have the shrink tube kind of on the wire while you're soldering, so once you're done soldering you can slide it on, but then also considering making sure it's not going to get too hot. So for instance, for this connection right here, I'd want to solder these two shorter leads onto the connector first and put their shrink tube on with these ends free, and then solder it here. If I soldered this end first and then I went to go put this connector on, I'd have to put the heat shrink really close to where the connection is, so it's more likely that it might heat up just from soldering the wires. Sometimes you'll be forced to do something like that, but if you're strategic and you think about it, you can usually find a way to make it work. And especially with these, you know, this is a like 3-wire connection here, so you know, I think this assembly was probably pretty complex because of these multiple big connections in a row. First connection I'm going to solder up is going to this battery. So I have my black and my red here. And then as far as taps, I have this 1 wire right here, which is going to go to the test switches, because the test switches will live right here. So even though this is like control power, which usually would come from, you know, around the box or like those connections, it's easier if I just tap off the negative wire right here. And then this red wire is actually the jumper between 2 wires or 2 batteries, and it doesn't have any jumpers on it, so that makes that one kind of easy. So keep in mind what I said about the shrink tube. I want to kind of plan out, you know, where I want this connection to go, and then I want this wire, you know, going this way to get to these connections. Because if I put it like this, you know, you'd kind of have excess, and it wouldn't be as clean. So it'd probably go like somewhere around there. I'll put that on, and then I'll also I'll solder a connector on here. To make the Y connector, I'll usually strip, see, about 1/4 inch, 3/8 of an inch off the smaller wire, and then I will use the wire cutters to make 2 cuts there, and then I'll just use a razor blade and like cut between, and then you can pull the wrap off. So things you'll need for soldering: got the soldering iron. I think that's 40 watt, which I'll use for my larger wire. Got solder, got flux, I got a lighter for the heat shrink. I'll got some hemostats. Use those for some of the Y connections. I use vice grips as a kind of holder for connectors. So this is not meant to be a video on soldering, but generally processes: put some flux in the wire, then heat the wire up, melt the solder so it's tinned, put some flux in the connector, and then heat the wire up in contact with the connector, and the flux will cause it to bind, and then put heat shrink on it. First I'll put flux in the wire, both ends. Tin it. key is for the solder to be kind of like absorbed by the wire. It gets all the strands. So to put it on a connector, I'll have the connector and vice grips. Put some flux in the connector. And then, because I already have solder on the wire, I can just kind of hit it real quick and it'll melt. Once I see the solder kind of like sink into the connector, I know it's good. There we go. One thing you want to be careful about on these is these pins are relatively loose, so you noticed how I only had the soldering iron in contact with it briefly. So if you heat these up too much, the pins the plastic will melt and the pins will kind of shift. To compensate, you can put the opposite connector in. So you can put the female connector in, you know, like this or something. Then that'll help prevent it move if you have that issue. Because I do it quickly, I don't have that issue, so I usually don't do this, but a lot of other people do. To make up the Y connector, I will, I've done this a few ways in the past. One, I'll just put flux on both of them and then clamp them together and then heat it up and feed solder in directly. Other times I'll pre-tin both of them and then clamp them together and then melt it. Because this is a small control wire, I don't really care too much. But for some of the bigger power connections, I'll put a little more effort to making sure I have good contact at that joint. Now they're all tinned. Use the hemostats to clamp them together. This can sometimes be tricky because they'll want to kind of like pivot or go side by side. Sometimes this doesn't work out perfectly the first time. In this case, because one of the wires was small, it went together pretty easily. Now I'll solder the black wire onto the connector. Put the heat shrink on there. Just like that, it's on. So I'll let it cool a little bit and then I'll slide the heat shrink over. And then for this one, because these ends are both free, for the heat shrink for this joint, I can slide one piece over the whole thing. But if I already had connectors on the ends, I would have had to put the heat shrink on this joint right here before I solder the connector on. Okay, to get the heat shrink on, I want to make sure that it sort of goes in those little recessed areas there. So what I'll do is I'll pull it back a tiny bit and then just use a lighter. Shrink it down a little bit. I got fans to blow the smoke away, so that's why the flame is impacted. So now I have them kind of slid in there. I can finish it off. There's the finished product. Now for the Y connector, like I said, because the ends are loose, I can just put it on like this. Hold it there and then shrink it down. There's the finished product. Now I'm working on the jumper between the second and third batteries. So this is the one I need to tap off for power for main drive, and the aux drive and control power. So I'll just really just give an overview of the approach. I'm going to start, this is the connector that will go to the third battery, so I'll probably solder this one on first, shrink wrap on, then I'll do the connection right here, and shrink wrap on, and do this connection, shrink wrap, this connection, shrink wrap, and then finally connect this back to the second battery connector. The reason for that is just so I can get shrink wrap on each of them sequentially, without having to have the shrink wrap on while I'm heating up the wire. When wiring up the solenoid connections, you need to consider whether or not a diode is necessary. If you're using the BC integrated board, it has diodes built in, so you don't need them, but if you're using a more traditional firing board, then you should put diodes going to the solenoid. They give a path for the sort of inductive kick of the solenoid to discharge after it fires. Otherwise, the kick could damage the firing board. So what a diode does is it allows current flow in one direction but not the other. So the diode's the little piece in the middle there. It's got a silver band on one end so that I view kind of like a shield, so this diode will let current flow that way, but it won't let it go that way, which is important. If you look on the red, when current's flowing, it's going from red through the component and then back to black. So when it goes here, the diode will prevent a short right there. Like if you install this the other way, it'll cook it and probably the firing board real quick. But there's kind of, when the solenoid de-energizes, there's this reverse induced voltage in the diode, kind of, the solenoid's over here. It kind of allows that to dissipate. This is the way I hook them up. This will go on my lead to each solenoid. So it ends up being kind of compact. So I'll just kind of strip off 2 areas in the middle, and then with this one I'll put shrink wrap over each exposed part, and then I'll put a larger piece over the entire thing, so it'll kind of seal it up, be pretty clean. I'll show quickly soldering up an XT30. These are smaller, so I'll use a smaller, like a 20-watt soldering iron for those. So I get my shrink wrap staged. So these ones, because they're so small, you need to be really quick with the soldering iron. There we go. So slide that shrink wrap over, shrink it with the lighter, and then put a bigger piece over the diode there. I have the wiring harness done and everything hooked up and powered on. So it's good to just do a bench functional test. Make sure all the systems work, so check the throttle. It's kind of loud, but it's fine. So both the inboard and outboard props are moving appropriately. See how the rudder works. Test the pump. Spin in the right way. Guns. Clicking is the solenoids and the test switches for the triples. So this all seems good. Now that everything is working or verified, I'll try to clean up the wiring a little bit as far as tucking it away or using different wraps or harnesses to kind of make it less of a rat's nest.